Okay, many of you maybe already knew how to do this before you even met me, but we're going to do it because it does have to do with exponents, okay? I gotta get a pen that works. Okay, write the following numbers in scientific notation. Now, all scientific notation does is it takes a number with a lot of digits and it just abbreviates it. Okay, that's all it does. That's the purpose of it. Now, there's one thing you need to do at the beginning, and it might not come in your mind, but it needs to. This number you look at here, 0.000054. Okay. Is that less than one whole or bigger than one whole? It's less than one whole, so put a little negative sign right there. Okay? That's going to help later to not drive you nuts. Now, guys and gals, you need to move this decimal so that it can only have one digit in front, and that digit cannot be a 0. Okay? So what you do, you're always going this way. Find the first number that's not 0. You're always looking this way right there. The decimal has to go between that number and the number after it, so you move it. 1, 2, count as you're doing it. 3, 4, 5, 6. So 5.4, you don't put the zeros at the beginning, it's just 5.4. Times 10, because every time you move the decimal, you're multiplying it by a group of 10. Well, you moved it 6 times, so it's 6. But it was a really small number that I just made bigger, so we need to put a negative on the exponent. That's why that's there. 5.4 times 10 to the power of negative 6. It's always times 10. Okay, now if you don't see the decimal, it's automatically at the end. So looking this way, find your first number that's not a 0. Well, right away it's the 6. It's always looking that way. Now move that decimal so it's between that number and the number after it, the 6 and the 7. By the way, this number was bigger than 1, obviously, so positive. By the way, those of you on virtual, the number was 670000000, 67, then 1, 2, 3, 8 zeros, okay? The actual number is 6,700,000,000, okay? 6,700,000,000. So you're moving the decimal so it's between these two. Count as you're doing it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So 6.7 times 10 to the power of 9. Now it's positive 9. Because when we shrink the number, which is what I'm doing here, I made it a smaller number, I compensate by that by making the exponent positive. When I take a small number and expand it, make it bigger, I compensate for doing that by making it negative. So again, less than 1 negative, bigger than 1 whole positive. Okay, I got some more. So that's a negative, that's less than 1 whole. Anytime you have 0 in front of a decimal, it's less than a whole, so that power of 10 is going to be negative. If you just want to put times 10 with a negative, that's fine, okay? Okay, looking this way, always looking that way. What's the first number you have that is not a, that's not a 1, or not a 0, excuse me, right there. So it's got to go right here. So 1, 2, 3, 4, 5, 6, 7, 8. So you put 4.06 times 10 to the negative 8th power. Okay. 0.00000007008. Okay. So again, it's a negative because that number we start with is less than 1 whole. So times 10. Negative, okay, and now move the decimal. Remember, it's got to go, the first number is right there. It's got to go between that number and the digit after it. 1, 2, 3, 4, 5, 6, 7, 8. So negative 8 is the power, and then my number is 7.008. Basically, you'll know if you did it right if you end up with one number in front of the decimal, and that number can't be a 0, okay? One number in front, not a 0. One number in front, not a 0. One number, not a 0. One number, not a 0. So you know you're doing it right. Okay, decimals here, so that's a positive, okay? So times 10 to the positive power, okay? You can put a positive or just don't put a sign. It's up to you. Okay, first non-zero number is a 4. So it's got to be between the 4 and the number after it. 4.709. And you're like, well, how do I know when to cut the number off? After you've written your last non-zero number, that's when to cut it off. Once you have nothing but zeros left, cut it off, okay? And you moved it 1, 2, 3, 4, 5, 6. So it's 10 to the positive 6 power. And some of you are like, how do I know if I did it right? Well, do you have one number in front of your decimal? Yep. Is it a 0? Nope. Then it's right, okay? One number can't be a 0. Okay, decimals here, so that's obviously a lot bigger than one whole. 1544 000 0000. Okay, so times 10, and the exponent's going to be a positive. Okay, so go to your 1, okay, because that's your first non-zero number, and the decimal has to go between that and the number after it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the power is 10. And it's 1.544. Okay, that's going to be a negative times 10 to the negative power. So looking this way, the first non-zero digit is 7. Okay. Now you're like, there's not a number after it. Well, you're going to put a 0 after it then, okay? Just 1 though. So 1, 2, 3, 4, 5, 6, 7. So it's negative 7 and then 7.0. Don't put the zeros on at the beginning, okay? Okay, and then the last one here. 8, 0, 0, 0, 0, 0, 0. 0, 0, 0. So the decimal starts at the end. If you don't see it, you put it at the end. That's obviously higher than 1, so times 10. It's going to be a positive power. So looking this way, the first non-zero digit I have is 8. Okay. So you need to move it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's to the 9th power, positive 9th power. And then we're just going to put 8.0. Okay. So you take a big, again, you need one number in front of the decimal, and that number can't be a 0. The exponent is how many places it was moved. You just count as you're moving it. Okay, the next part's a cakewalk. Write the following numbers in standard form. Okay. Now it's in scientific notation. You're going the opposite way of what you did on the back side. You can just use a calculator. 2.7 times 10, hit the caret key right there, 6. There it is. It's a lot quicker than moving the decimals. Put commas, please, between 2,700,000. So again, it's a positive exponent, so the actual number's bigger than one whole. Okay, 1.69 times 10 to the power of negative 4. Okay, makes sense. A negative exponent insinuates it's going to be a really small number. Right there. 7.8 times 10 to the 8th. Makes sense. Positive 8 is going to be a really big number. So 780 million. Okay, 3.2 times 10 to the negative 5th. Right there, 0.000032. Okay. Now the next part, this is actually pretty easy too. You're simplifying each expression, write each answer in proper scientific form. What you have is a multiplication problem, okay? Sometimes it's multiplication, sometimes it's division. And you need to multiply the numbers in scientific notation together, and you need to write your answer in scientific notation. Now here's what you want to do. You have 6 times 10 to the 4th in a parentheses times 4.8 times 10 to the 2nd in another parentheses. Now it's all multiplication. Now what you need to do is break up the multiplication. Take your base numbers first. Take 6 times 4.8 and then multiply your powers of 10. 10 to the 4th times 10 to the 2nd. So you take 6 times 4.8, okay, 228.8. Now on your base 10s, okay, you add the powers, 4 plus 2. It's multiplication, so we add the powers. It's 10 to the 6th. Now you're like, so that's the answer? Well, not quite. Look here. That number is higher than 1, okay? You need to move the decimal so there's only one digit behind it, okay? It can't be a 0. So you need to move it behind the 2. You moved it one place, and you moved it to the left, so when you move it to the left, you add to your power of 10. Add 1, because you moved it one place, okay? So now the answer is 2.88, because remember, we can only have one non-zero, one digit in front can't be a 0. See here, there were 2 digits. That's not going to work, so you need to move it so there's 1, okay? And 6 plus 1 is 7, so 2.88 times 10 to the 7. So if you move it left, you add to the exponent. Moving it right subtracts from the exponent, okay? So you might want to write that. Move left, add to exponent. Moving it right, minus from exponent. Okay, next problem, same thing. So I take 0.6 times 10 to the negative 3rd in the parentheses times 0.2 times 10 to the negative 5th in parentheses. So we take 0.6 times 0.2 and then 10 to the negative 3rd times 10 to the negative 5th. So we take 0.6 times 0.2, 0.12. Then 10, you add the powers, negative 3 plus negative 5, that's negative 8. Now, first digit that's not a 0 is a 1. The decimal is supposed to go between the 1 and the number after it. So you move it once. Now you moved it to the right, okay? So when you move it to the right, you minus 1 from the exponent. So when you make the number bigger here, you make the exponent smaller. When you make the number smaller, you make your exponent bigger, okay? So it's 1.2 times 10, negative 8 minus 1 is negative 9. Okay, there you have it. Okay, next one. 0.5 times 10 to the 4th times 6 times 10 to the negative 14th. So you're basically just breaking up the multiplication problem into a different order. 0.5 times 6, 3. You're going to put 3.0. And then on the base 10s, 4 plus negative 14 is going to be negative 10. Okay. Now, you don't have to do anything because the first number you have that's not a 0 is 3, and the decimal's already behind that, so we're good. 3.0 times 10, negative 10. Again, to check your answer, there's a decimal, there's one number in front, that's good, and it's not a 0, that's good. Okay. Okay, 0.6 times 10 to the negative 8th power times 0.3 times 10 to the negative 3rd power. So I take the 0.6 times the 0.3. then 10 to the negative 8 times 10 to the negative third. So that's going to be 0.18. And then add your powers. It's negative 11. Okay, is a decimal in the right place here? No, it's supposed to go behind the first non-number I have. That's not a 0. Go looking that way, so you need to move it. 1.8. Did you move it right or left? You moved it right, so then you have to subtract from the exponent. Okay? So that's negative 12. So it's 1.8 times 10 to the negative 12. Okay, now on the back side, you're dividing, but that's the same concept as what you just did. 2.6 times 10 to the 14th divided by 1.3 times 10 to the 4th. Now you break it up as a division problem. Okay, 2.6 divided by 1.3. It's going to be 2, put 2.0 down. Now, in scientific notation, you know how when we've simplified these before, you always get rid of the smaller exponent? Not in scientific notation. You always get rid of the one on the bottom. So minus it from the top. So that's 10 to the 10th. Okay, decimal's in the right place. Okay, 2 is the first non-zero digit. It's in front of that. I got 1, so 2.0 times 10 to the 10th. Then 4.5 times 10 to the negative 7th power divided by 9 times 10 to the negative 3rd power. So we're going to go 4.95 divided by 9. 10 to the negative 7th, 10 to the negative 3rd. So I divide 4.5 times 9. 4.5 divided by 9, sorry. 0.5. And then always get rid of your bottom when you have to do scientific notation. So you subtract negative 3, okay, which is like plus 3, and that's going to be 10 to the negative 4th power. But, what's the first non-zero digit you have? It's a 5. The decimal has to go between the 5 and the digit after it. Put a 0 if there is no digit. So you need to move it once, and you moved it to the right. When you move it to the right, you subtract. When you make the number bigger here, you subtract from the exponent. So it's 5.0 times 10. Negative 4 minus 1 is negative 5. So again, you should always end up with one number in front of your decimal. Can't be a 0. Okay, 4.2 times 10 to the 8th divided by 2.1 times 10 to the 11th. Okay, so I divide here, it's 2. Put 2.0 on that. That's going to be 10 to the negative 3rd. Now I don't need to move the decimal because the first non-zero digit's a 2 and the decimal's after that number. So that's good. I don't need to change anything. Okay, 5.1 divided by 1.7, and then 10 to the negative 2nd, 10 to the negative 5th. Okay, this divided by this is 3, 3.0. Then you take out your smaller exponent and subtract that from your top. So you're subtracting a negative, which is plus, and then that's going to be 3. Okay. Looking this way, first non-zero digit's a 3, and the decimal's right behind it, so I don't need to move it. So 3.0 times 10 to the 3rd. Okay, now story problems. Okay, the story problems are a little bit weird, but they're not hard to do. They go pretty quickly. Find my bag and get my... And you can do these on notebook or whatnot. Here's the first problem. A large cube is made up of many small cubes. The volume of the large cube is 7.506 times 10 to the 5th cubic millimeters. Really big number. The volume of each small cube is 2.78 times 10 to the 4th milliliters. Okay? How many small cubes make up the large cube? Okay? Now, here's what you want to do. Just take my advice here. The one with the higher power of 10, call that 20. Okay? The one with the smaller power of 10, call that 2. So let's reread it. The volume of the large cube is 20 cubic millimeters. The volume of each small cube that goes inside it is 2 milliliters. How many small cubes make up the large cube? What would you do at 20 and 2 to find out how many small cubes make up the large cubes? If the large cube's 20 and each small cube's 2, it'd be dividing, okay? So you make a division line, and instead of dividing, okay, 20 by 2, you divide 7.506 times 10 to the 5th, and then 2.78 times 10 to the 4th, and then it's just like you were just doing, okay? Okay, so 7.506 divided by 2.78, 2.7. And then minus 4, that's 1, so times 10 to the 1st, okay? And the decimal's in the right place, okay? So 2.7 times 10 to the 1st is your answer, okay? And it says how many small cubes, you just put cubes, okay, with your label. Okay, next example. The entire floor is made up of many square tiles. The area of the floor is 8.334 times 10 to the 6 square feet. The area of a tile is 3.324 times 10 to the 3rd square feet. How many tiles make up the entire floor? Okay. So again, your higher power of 10, just call that number 20 and that number 2. So if I have 20 square feet and each tile is 2 square feet, how many tiles? Well, you divide 20 by 2 once again, okay? So, but instead of 20 divided by 2, it's 8.334 times 10 to the 6 divided by 3.324 times 10 to the 3rd. So 8.334 over 3.324, and then 10 to the 6th divided by 10 to the 3rd. Okay, just put 2.5, round to 2 decimal places, 2.51, not second PRB equals. 2.50, but the 0 becomes a 1. Times 10, move that 3 up, so it'd be minus 3, so 10 to the 3rd. Decimals in the right place, okay, the first digit's a 2, and it's after that, so 2.51 times 10 to the 3rd. How many tiles? So that's how many tiles you'd have. Okay, there are 7.228 times 10 to the 4th acres of land. The land is made up of deer plots that occupy 3.16 times 10 to the 3rd acres of land. How many deer plots make up the land? So again, let's call that 20. Let's call this smaller power of 10, 2. So I got 20 acres of land. There's these deer plots. Each of those make up 2 acres. So how many deer plots? Well, you divide again, okay? Dividing would be the operation. So I just divide with the scientific notation numbers. 7.228 times 10 to the 4th divided by 3.16 times 10 to the 3rd, okay? 7.228, 3.16, then 10 to the 4th, 10 to the 3rd, okay? Okay, 2.29 times 10 minus 3, and that would be 1, okay? So 10 to the 1st power. Okay, then the next ones. A light year is a distance light travels in 1 year. Light travels 5.9 times 10 to the 12th miles per light year. How many miles does light travel in 3 months? Now, this is how to do this. The operation's multiplication, okay? But you want to write this out. Write 5.9 times 10 to the 12th, and it's per year, per light year. So you're going to put times the years. Now, how many years do we have? Well, it doesn't give us years. It gives us 3 months, okay? So you cross out the years and put 3, but then how many months are in a year? 12. So you write it as a fraction, 3 over 12, because there's 12 months in a year, okay? So what you're going to do now is you're going to take 5.9 times 3 over 12. You can do a fraction. And then you're just going to have your 10 to the 12 sitting there. Okay. So 5.9 is just a multiplication operation. And you get 1.48. Okay. So 1.48 times 10 to the 12th. And that's perfect. Decimal's in the right place, so there's my answer. Okay, so how many miles? That many miles. Okay. Okay, next one. A light year is the distance light travels in 1 year. Light travels 5.9 times 10 to the 12th miles per light year. How many miles does a light travel in 2 years? So, this is a multiplication problem. If you just want to replace that with 20, that's fine. 20 miles per year in 2 years, you take 20 times 2. It's a multiplication problem. So 5.9 times 10 to the 12th times the years is how that's done, okay? And this time I actually get years. It's 2. I don't need to make a fraction because it's years. So I take 5.9 times 2. And then the 10 to the 12th just sits there, okay? So 11.8, and then 10 to the 12th. But the problem is you need to move the decimal because you have 2 digits in front of it. You need just 1. So you move it. You moved it left, so you'd add 1, and it would be 13. So 1.18 times 10 to the 13th power, okay? Okay, then our last problem. A light year is a distance light travels in 1 year. Light travels 5.9 times 10 to the 12th miles per light year. How many miles does it travel in 90 days? So again, if I put that as 20, okay, I'd be taking 20 times the years. So again, it's a multiplication problem. 5.9 times 10 to the 12th times the years. Okay. So the years, ooh, it's not years, it's 90 days. How many days are in a year? So you underline it. How many days are in a year? 365. Okay. So we have 5.9 times 10 to the 12th times 90 over 365. So I take 5.9 times 90 over 365, and then the 10 to the 12th just sits there. 5.9 times 90, ABC 365. 1.45, the decimal's in the right place. It's after the first non-zero digit. So I just write 1.45 times 10 to the 12th.